Alright, so this is a U try right here, guys. Alright, I'm just picking up. I'm going to solve the rest of this on the front right here. Alright. So yeah. Alright, if you notice, this is the same equation we use on the front on this other page. So you actually have the equation for it. Alright, this is the same one for that exponential problem. Alright, so anyway, man, I'm going to call him Bart. Bart opened a new sporting good business that has recorded his sales each week. To break even, Bart needs to sell $48,000 worth of merchandise in a week. Assuming the sales trend continues, use a graph and an equation to find the number of weeks before Bart breaks even. Alright, so it says create an equation. We already did that. Alright, the equation we created was going to be f of x, or y, guys. You can say y. But f of x equals, we said 22,727.15 times 1.1 raised to the x. Now, I know you're like, where did we get this equation from? Remember, man, right here on the calculator, we did this when we entered our information into the calculator. All right, and then we graphed it. All right, remember we did this in list 1 and list 2. All right, same data, and then we went stat, calculate, and went to exponential, all right, regression. Okay, so here's the data. All right, now we have our equation. Okay, now right here it says by plugging in the equation, you find in part A to y1. All right, you might have to adjust the window. All right, so look, let me show you how to do this part right here where you got to adjust the window. Okay. What happens is this. On your calculator, you can take your function and actually plug it in. All right, so let me clear out these two lists. All right, now if you put that equation in, 22,727, all right, times 1.1 raised to the power of x, like so, hit graph. All right. This is from negative 10 to 10 and 10 to negative 10 to positive 10 here. All right, we're going to fix this graph so we can see. All right, so what we're going to do is you can go to window right here. Wait on the window to come up. All right, here's the window, guys. And what we want to do is, I know it says X on my screen. All right, it says X min and X max, but on your paper it's going to say Y min and Y max because the graph is going up. All right, we know it doesn't go past 5. All right, you see 5 right here. So we're going to fix the screen real quick. We want Y to go up as high as possible. So we're going to say 60,000. We're going to start from 1. The Y minimum would be as low as it's going to be, and we're going to go up to 60,000. All right, we can do this in our graph. Not calculator. So there we go. Now we can see the graph forming. All right, it's going up to 60,000. Okay. Now the next thing we're going to do is we're going to use the trace, guys. All right. It says once you graph, you can go to the table and find where the Y value is 48,000, or just trace until you see it. All right, so the first way you can do it is you can go to the table, all right, and you can scroll to where it says 48,000. All right, this is close but not quite 48,000. All right, so what we're going to do is we're going to use this to trace. All right, we're going to go trace. And we're going to trace this thing until we get to 48,000. Like so. All right, so we still got about the same dilemma. So we're looking at about 7. All right, 7 weeks. All right, or yeah, about 7 weeks. Or how about we go ahead and just round that, right? We'll say 8 weeks. We'll round it to 8 weeks, all right? Oh, so in 8 weeks, guys. All right, for reach is 48,000. Okay. All right, and then again, you see how it says he needs to sell. Bart needs to sell $48,000 worth of merchandise. That's why we're looking for 48,000, guys. Okay, so about 8 weeks. All right. Now, let's say, could you have found each week? Found the week in which Bart hit 48,000 using it algebraically? You absolutely can. All right, and I'm going to show you how to do this algebraically as well. All right, if we're trying to get 48,000, right? If we take that and set it equal to our equation, $22,727.15 times 1.1 raised to the power of x. All right, the first thing we can do here is divide by 22,727.15. So I'll do that on both sides. 0.15. All right, that's a 1, guys. All right, so excuse me. That's a 1. All right, 0.15. Now, when I do that, that's going to give me 2.112. All right. Now, this cancels on this side, so what's left? 1.1 to the power of x. Now, I got to find my exponent. All right, I got to find my exponent. So how do I solve this here? I'm going to rewrite this as a log. All right, so how I rewrite that is log, all right, base of 1.1. All right, my argument is 2.112, and it equals x, my exponent, all right? Now, this left side right here, we can solve this in the calculator, guys. All right, we take that log of, remember, it's log of your argument divided by log of your base. All right, so if we go, let me clear this out so you can see. If we go log of the argument, which is 2.112, all right, and divide that, make sure you close your parentheses right here. Divide that by log of 1.1, that gives us 7.8. All right, 7.8. So what we see is that gives us 7.8 equals x. So that's what we saw in our calculator, guys, which is about 8 weeks. All right, 8 weeks. All right, about 8 weeks, which we had said. Okay. We'll write it again. That's it. So this is now 1, video 2. All right, there's some homework that's attached to it, man. You guys get that done. Use the video in case you need help, okay? See you tomorrow.